All right, class, welcome back. We are now on section 4 of chapter 12, and that is on page 380 in your books here. So as we move through here and we move to the second part of chapter 12, what we are working with now is just as when we did the lump sum compounding interest, where we invest a lump sum and we get a lump sum at the end. And we know that with annuities, let me go back. When we did the lump sums, we could figure a present value, what we need now, and a future value, what we will have. Same thing with annuities. We just did in sections 1 through 3, we were calculating the future value of annuities at particular payments, compounding periods, and years. So we were figuring the future value out. Now what we want to do is figure out a present value, and there's a special situation for this in terms of a present value for annuities. A present value for an annuity is the situation of that you want to be able to make a certain number of payments out of an account, and by the time you make the last payment, you've used up all your money. So basically, when we're figuring out the present value of a ordinary annuity, it's what lump sum do I need now so that as I make payments out of that lump sum every month and I earn interest on the remaining amount, how much must I put away now to make all those payments for all those years, and that on my last payment I have zero. All right, so one situation that they give is at the top of 380 is that let's say a company owes $10,000 interest to bondholders at the end of every month. So these are people that have invested in a company and they have to pay out a total of $10,000 every month. All right, and they have to do this because the bond is for a certain amount of time for 3 years. So what they want to figure out is how much money do we have to have in an account now so that when we pay $10,000 a month out for 3 years, that on my last payment I'll have $0. But it's in an account that's earning interest. All right? So what lump sum do I need now? At a particular interest rate, when it's compounded monthly, when I make my payments, how much do I have to have now so that when I make my payments over 3 years, that at the very end I've used up all the money. I've used up all the interest earned and all the principal that we put away in the lump sum to begin with. That is a present value annuity formula. Okay? So that is what we are figuring out. The present value. What lump sum do I need now that as I pay it out every month and the interest I earn on what's left in the account after a payment, all right, all that interest accrued, that when I make my last payment, I have $0. That is the present value of an annuity. And again, up here, it gives the definition. The present value of an annuity is the lump sum amount of money that must be deposited now to provide a specific series of equal payments. That's what the annuity is, equal payments over equal time in the future. Okay? So that's what we're figuring out. Now, the next 2 sections we are going to figure using tables. And again, just like with the future value, we can have an ordinary annuity where the payment is made at the end of the compounding term, or annuity due, which the payment is at the end, or the beginning. I said that backwards. Beginning. Annuity due is at the beginning of the compounding period. So what we're going to look at first is the present value of an ordinary annuity, end of the compounding period, and we're going to use tables. All right, so again, just like we've been doing, we have to calculate the interest rate per period. So that's the nominal rate divided by the periods per year. How many compounding periods per year? We have to know the number of periods. That's the little n. So we have to do I and little n, years times periods per year. And from the table, we'll locate the factor, and then we multiply that factor. Multiply the table factor by the annuity payment, and that's how we get the present value. So we will use present value tables, and those are found on page 382 and 383. All right, very similar. The interest rate per period is along the top, and The total number of periods, small n, is along the left side. All right? So, how much must be deposited now at 9% compounded annually is once per year, to yield an annuity payment of $5,000 at the end of each year for 10 years? So how much do we need to pay now, put in now, so that we can make $5,000 payments at the end of each year for 10 years? So that we're really looking for, we need to be able to pay out $5,000 a year for 10 years. We need to be able to pay out $50,000, but just $5,000 at a time per year. So how much do I need to put in now, compounding annually at 9%? So the rate per period in this case is 9% because it's only one time per year, 9% divided by 1. The number of periods is 10 because it's going to be 10 years compounded annually once per year. So little n is 10, I is 9%. So from the tables, we find the factor of 9% for 10 periods. All right. And if I look at the table, 9%, oh, that's going to be the second table over here, 9%, 10 periods. My factor is 6.41766. So we can quickly find that. And so then I'm just multiplying the payment of $5,000 times that factor, 6.41766, which is $32,000. So I need to put away $32,000 now to be able to make 10 payments of $5,000. So if you wanted to know the interest you're going to earn, you would take, hey, those are the payments at future value, $50,000, and subtract out what the present value is, $32,000. All right, and that would, so it's just short of $18,000 interest that I'm going to make. All right, so you would have to put away $32,000 now at 9% compounded annually to be able to make 10 payments of $5,000. All right, that's the present value of an ordinary annuity. All right, so I'm going to pause it right now. You guys get to practice here, exercise 4. Hey, the Broadway Movieplex needs $20,000 at the end of each 6-month movie season for renovations and new projection equipment. How much will be deposited? How much must be deposited now at 8%, present value because it's now, 8% compounded semi-annually. So it's compounded semi-annually. That's the same every 6 months is when they have to make the payment. So it's ordinary, or I'm sorry, it's simple. So we're good there. To yield an annuity payment for the next 6 years. So semi-annually for 6 years at 8%. All right, they need $20,000 semi-annually for 6 years, compounded at 8%. Go ahead and figure that out from the table. Again, these are all having to find the I, the small I, and the N. That's what's important. All right, go ahead and figure that out, and I'll come back with the answer.